I'm trying to make some breakout boards and I'm short on parts. Specifically, I need some barrel jack connectors. And since I don't have the patience to have them shipped to me and wait for them, let's commence with the ripping apart. So this is an interesting little beast. It's a lamp. It has a clip on it, so it's obviously intended to go on your work surface, and it has a barrel jack connector loose on a wire, which I assume is because you might have it clipped to the underside of a table and have trouble reaching under there, so you can lift this up around the lip of the table or desk or bench or whatever, and hook it in from there. But the most interesting feature is that there's no obvious power switch. It took me forever to figure out how to turn this thing on until I noticed this tiny little icon here. It's capacitive, or I assume it's capacitive anyway. So you touch low, medium, high, low, medium, high, and you hold 2, 3 to turn it off. I don't know if this is a simple Darlington transistor thing, or if it's a part I'll even be able to get off, but it's worth a shot. So the first thing I notice is inside this clip, the power cable is hooked in, and there's a shaft that seems to go down and continue through this. So there must be enough slack in here, because it's not wiggling. So we get to find out if there's enough slack or if it's connected to some sort of conductor down the length of it. So the spring is held in with some sort of hex bolt, but I'm not too interested in that. First, I'll try turning, and that doesn't do anything. Oh, but it's a nut. This part in here where the shaft is, it's actually a nut. So perhaps I will get my hex key set out, if I can find it. There we are. Now we try to find the size that fits in this mess. That almost does. Unfortunately, almost is not good enough. There we are. Let's see if this will come loose. Not really. We may have to resort to violence. Ah! Violence will not be necessary. Isn't that lovely? When you're trying to undo a bolt like this, it's wise to keep your finger on the other side to feel for it turning, because you don't want to discover that you have been undoing a bolt for the past minute and really just turning the shaft on the other side. That is what we call embarrassing. But indeed not. That is just going to come right off. Yep. Let's undo the one on the other side. Since there's plenty of tension, it seems. One might even say too much. But the good news is, I'm going to get a free spring out of this. Never turn down a free spring. That's the kind of thing that is an absolute pain in the butt to get, especially when it's thick and strong as this. And now I can see I'm just turning the shaft, unfortunately. So I'm going to try to slip this spring off of the shaft. And it's on the floor, where I will find it someday. So now I can go ahead and get this off the rest of the way. Ah, I was all set for an effort, and I just slid it out. So now you can actually see what's going on in here. The cable goes down this little shaft. So there's an odd little hook here, which I will simply break open. Some sort of plastic or rubber snap. What an interesting idea. But in any case, it is done. So now I have this bolt here that I will undo. Let's see if I can just use the pliers. Can I be lazy? Will the universe let me be lazy? This is the most deformed, disturbing looking nut I have ever seen. That one little spot, as soon as it lets go, we have joy and wonder. Try and get it loose enough I can just turn it. There we are. You can see this gigantic nut that was holding it on, and I just realized it was still plugged in. So that's good. Remember to unplug your stuff, please. Don't be me. And a very good question is how on earth they even got this on here, because it's not coming off here. So it must be connected through here. Now that is a fascinating little mystery, isn't it? Well, I want to try and keep this entire thing intact. So hopefully I'll be able to disassemble from the other side and get it loose. So always look for screw holes, and there are none, but there are 4 suspicious spots that look like they are covered screw holes, like here. So we're going to pry up these spots, and unsurprisingly, underneath the rubber is a screw. And that was actually glued in. This does not seem to be too cheap of a design. So I'm carefully pulling out these little spots that were cleverly hiding where the screws go as my headset continues to fall off. I would love to use Louis Rossman's microphone, but I certainly do not have over $700 for a microphone. I'm glad he does. I'm glad he's so successful, but wow. So the rest of us have to make do with what we have. So I'm simply taking apart these 4 screws. Remember when you go to vacuum your floor in a few weeks, that you're going to hear a crunching sound from all the screws you've dropped. Once again, I need to magnetize my screwdrivers. But remember to keep tension on whatever you're unscrewing, just in case. All right, so a front casing comes off. What looks like, well, here's the wires that come through. We see a red and a white. It's fairly standard. Oh, a red, white, and a black, in fact. Interesting. But the most important thing is I see 2 more screws. These seem to be holding this light panel on. I'm not sure if it is a light panel or just something that diffuses the light. I would bet on it diffusing. There's probably a small array of LEDs back here. And remember, until you know there's no capacitors you're about to touch, be careful. Aha. So there is a small circuit board. From the central shaft, there is a red and black soldered onto the board. And then coming off the board, there's a black and a white to the panel. So I would like to preserve these parts, but I'm not worried about preserving the circuit board as much. So I will snip the wires close to the circuit board. And now let's see what we have. The back of this is metal. I'm guessing this is a heatsink. The black and white wires go all the way through. If I pull gently, they don't come loose. And they happen to go to both sides. So I'm guessing that there's some sort of circuit going across. So if I can peel off this metal, there we are. The metal just comes off. And there we are. So it's not for heat sinking, it's more for reflection. So here we have 2 strips of small surface mount LEDs. That's neat. I don't see any way I'll really be able to separate these. They're pretty well wired together in series or parallel. But at least I have some LED strips I could use for lighting on something else. So the LED strips were on either side. And here was this material. So presumably the metal reflected the LED's light inward and it diffused through this material, which is just 2 stickers. 2 somewhat translucent stickers on a piece of plastic that is super cloudy for maximum refraction. So that's how 2 LED strips illuminated a nice, smooth, and even rectangle. Very creative. Perhaps I'll hang on to this as well in case I ever want to create a subdued lighting effect. But now back to the meat and potatoes. We have a power cord to extract. That appears to be just a rubber mounting. There's an inductor here. Anytime you see a coil of wire, that's an inductor. If there's a motor, it could be that, but there's certainly no motors in here, so that's a regular inductor. I don't know enough yet to know why there's an inductor in a light. Oh, but actually it would be the transformer, wouldn't it? It probably steps down voltage or something. In any case, as my learning proceeds, I'll figure out more of what inductors are good for. For right now, we just see voltage lines, LED supply lines, resistors, capacitors, and 1 inductor and not much else. A very, very simple light driver circuit. But the best news of all is I found more screws, which seem to be holding this top housing on. Make sure to hold on to it so it doesn't rip your wires. And indeed. So that was actually tied in a knot around a little post. That's their cable management strategy. And since the circuit board seems to be glued in, I will go ahead and snip these wires. And this slides off. Let me take this knot out of the wires. I'll cut it short if necessary, but this seems to want to just come out. There we are. Whenever you're pulling wires, grab onto the wires themselves because the thing they're attached to might be loose. But the question still remains. But now it's answered. So we have the wires coming through here and I pull, and these are pulling with it. So I'll just be able to pull these wires all the way through. And indeed, it was not being conducted by the metal. There was a wire going all the way through the shaft, which is impressive because this thing is quite articulated. Hang on to this too. A nice articulated arm like this, you'll definitely find a use for that. So it's impressive to me that they managed to get this in there without it wiggling, but also without it snapping. So now I will pull the wires through there, take off the clip, take off the nut, and we have a nice female barrel jack connector with 2 wires I can strip and solder onto something. And I can shorten it as much as I need. So we came away with LED light strips, a plastic diffuser, a spring and articulated arm, and a barrel jack wire. Like I said many times, buying the parts is much cheaper, much easier, and much faster even when you count shipping, as long as you order it in advance of when you want to do your project. But once again, we've learned. We've learned one more way to make a nice diffused light setup. I've learned that there is some reason to have an inductor on what is just basically a lamp. Perhaps it has something to do with the capacitive switch, which I did not find. The power touching is on the other side of the circuit board that's glued down. And I suppose I could try... Oh, but that is actually melted plastic. That's one way to mount it. They melted the corners of the plastic after they put the circuit board in, which made the plastic run just a little bit to hold it in. But it's also glued, so I can't simply slide it. That is ingenious. That's like soldering with plastic. Pretty cool. So I'm going to set this aside until I figure out a way to safely get the circuit board out of here without damaging it, and see if I can't figure out how this capacitive switch might work. Or if nothing else, I might be able to cut around the board and reuse it as it is. Finish one project and it spawns another one. So while I go find something else to rip apart, I'll be seeing you.